Hello viewers, welcome to Lessons with Philip, and today's class will be centered on circle geometry. Now, in our previous classes, we were able to discuss some properties of a cycle, whereby we'll be able to explain segment, sector, arc, diameter, and circumference of a circle. We'll be able to explain radius, the perimeter of a segment and sector, and also perimeter of a circumference. Now today we want to discuss the angles in a circle. Now, how do we identify some angles in a circle? There is a law that governs the identification of angles in a circle, and that law is known as theorems. Now, we'll be going straight to circle theorems. Circle theorems. Okay? This will be our subtopic for today. Now, there are like 6 theorems which I want to identify today. Now, let's go. Theorem 1. Theorem 1. Now, before we go to the circle theorems, we have been able to explain in one of our previous classes that I took that we explain angle theorems. You can check that in one of our classes. And I've been able to explain the angle is a distance between two lines. If I have two lines that meet, if a two line meets at this point, this is one line. Let's say I call this line AB, and this second line is line AC. Now these two lines meet at this point. Now the distance between these two lines, are known as angle. Okay. Now that is what we know as angle. Now in this topic, in our previous class, I've explained the different angle theorems, whereby we've discussed about straight line angles, we've discussed about corresponding angles, we've discussed about alternate angles, we've discussed about angles in polygons, angles in triangle, angles at a point, and whereby we say sum of angles at a point equals to 360 degree, and sum of angle on a straight line equals to 180 degree. Now let me go deeper a little bit. Now we said if we have a straight line and some angles are on this straight line, if you add them together, they will be equals to 180 degree. And we have also explained in that class, in that previous class, we've explained that when we have a point, the angles that emanate from that point, their sum will be equals to 360. If you add all these angles that emanate from that point, they will be equals to 360. Now, also, we've been able to explain that when we have two opposite angles, if they're opposite, how would they be opposite? When we have two lines that cross themselves, those angles that are opposite themselves will be equal, and that is what we call opposite angles. Vertically opposite angles are equal. That is the theorem. Now, another theorem says corresponding angles are equal, which I've been able to explain deeply in one of our previous classes. So you can check that class to understand better. So let me go straight to angles in a circle. Now, if I want to explain the angles in a circle, we need to understand the theorems that governs these angles. Now, the theorem 1. Now, theorem 1. Now, theorem 1, which I can call the midpoint of a chord. Now, the theorem says a straight line joining the center of a circle to the midpoint of a chord is perpendicular to the chord. Okay? In other words, when I have a circle, assuming that I have a circle, pardon my circle, I think I try a little bit. Okay, now if I have a circle and this is the center of this circle, Now, assuming that I have a chord, which is not a diameter, assuming this is my chord. Now, this chord has a midpoint. The midpoint is the half of the chord. Let's assume that this is the midpoint of the chord. Now, this theorem says that when we have a line that is drawn from this center of the circle to bisect this chord, the law says that line that is drawn from the center of the circle to this chord is perpendicular. That shows it's 90 degrees. Anytime when you say perpendicular in mathematics, it means they are referring to angle 90 degrees. Okay? Now, this law can still be stated that a straight line that is drawn to bisect a chord. Any line that is coming from the center of the circle to bisect a chord, they said that line is perpendicular to the chord, or that line is at 90 degrees to the chord. Okay? Now, that is the first angle you must be able to identify in a circle. Okay? Now, if this is A, if this chord is AB, and this center is center O, therefore, my angle, if this point is point M, the midpoint of the chord is M. Therefore, this angle OMB is equivalent to OMA, which is equivalent to 90 degrees. My angle OMA is equivalent to 90 degrees. That shows that this angle OMA, I'm putting the angle sign on M because the angle is at M. Okay, I've explained this. Now I can decide to put the angle at the front. Angle OMA, I can decide to put it at the front. Okay, it's the same way. Those are the ways by which you can identify an angle. Okay, now that is the first law. Let's go to the second law. Theorem 2. Theorem 2. Theorem 2, okay? Theorem 2 is a segment, angle in a segment, okay? Angle in a segment. Okay? Now the law says that angle in the same segment are equal. Okay? That shows that you need to understand a segment, which we've explained in the previous class. Now, if I have a circle, this is my circle. Now, what is a segment? If I draw a line like this, now all this is a segment. Okay, now this one is also a segment. So I have a minor segment and a major segment. Okay, now the law is saying that if I have an angle that emanates in this segment, the one that is not painted now is also a segment. If an angle emanates from this segment, okay, this is an angle. If I bring another angle from this segment, okay, this is another angle. The law says that these two angles will be equal. This angle and this angle will be equal. So if this is x and this is y, automatically my x is equals to y. What is the reason? Angles in the same segment are equal. Angles in the same segment are equal. If they are more than that, if I still have another angle originating from this same segment, then this one and this one and this one would definitely be equal. Somebody please take notes. If I have a circle like this and an angle originate like this, and I have another angle like this, take note, this angle and this angle are not equal. Somebody's asking me why. Because this angle, this first one, originate from this segment. Can you see? That is its own segment. But the second one originates from this segment. Can you see that they have different segments? This angle has a different segment. This one has another segment. That shows that the two angles will not be equal. Okay? Now, they must come from the same segment. That's why I use the line to indicate that they come from the same segment. Okay? Now, that is the second theorem. Okay? Now, let's go to theorem 3. Okay? We're getting there. All right. Theorem 3 says angle in a semicircle is a right angle. Okay? Now, let's say I have a circle, and this is the center of this circle. How do you know a semicircle? A semicircle is half of a circle. So if I have a line which is a diameter passing through the center of the circle, which is center hole. Now, if any angle comes on this semicircle, it is known to be right angle. Okay? Now, if I draw an angle from this semicircle, the law says that this angle is right angle. The angle subtended in a semicircle is right angle. Angle subtended in a semicircle is a right angle. Okay? Please take notes. If an angle is subtended in a semicircle, any angle that comes or that is subtended by a diameter is a right angle. Okay? And this is this. If this is A, B, C. Now, therefore, my angle ABC equals to 90 degrees. Okay? Now, that is how to name an angle, which I've explained in one of our previous class, angle theorems. Okay? Now, let's go to another theorem. This time around, theorem 4. I told you I want to give us 6 theorems. Okay? Do you know that apart from these 6 theorems I want to give, there is another theorem which we call tangent theorems. Oh, we'll also do that also. Okay? But let's focus on this. Now, theorem 4. Theorem 4 says angles subtended in the center of a circle is twice an angle subtended at the circumference of the circle. Okay? Now, the law says that when we have a circle, okay, please don't mind my circle, it's not that perfect. Now, when we have a center of a circle, if an angle is subtended in this center of a circle, let's say this is the center of the circle, and I get an angle. This is an angle subtended at the center of the circle. If another angle is subtended at the circumference, okay, this is another angle. Is twice the angle it's subtended in the circumference. Now, this is the angle at the center. Don't forget, this is center hole. If this angle is 40, for example, Now, this angle will be 20 because the angle that is subtended at the center of the circle is times 2 of the one that is subtended at the circumference. So, if this place is x, automatically this place will be what? 2x. Okay? Now, in another way, in another form of this, you can have a diagram like this. Assuming you have a circle, and this is the center of the circle. If I have this, and I have this, okay? The angle that is here, and the angle that is here, if this place is 2x, so this place will be x. So automatically, the angle that is subtended at the center of the circle, if this point is point O, it is twice the one that is subtended at the circumference of the circle. These two are the same way. If you check, somebody's asking me, I did the same. If you count the lines, 1, 2, 3, 4. If you count this one, 1, 2, 3, 4. It is just the shape. The shape is different, but it is same illustration. So the angle that is suspended at the center of the circle is times 2 of the angle at the circumference. Don't worry, we apply this law in our coming class. Okay, now that is that. Let's go to another law. Let's go to another law. This is one of my favorite topic. Okay, all right. Let me clean the board and we explain the last two theorems. Okay? Now we're going to theorem 5. Now, theorem 5 says when we have angles, let me write it like this: opposite angles of cyclic quadrilateral are supplementary. That is, their sum is equal to 180 degree. Okay, let's go. Let's illustrate it. If I have a circle, okay, and I have a cyclic quadrilateral, okay, 2, 3, 4. Now, this angle and this angle, if this is x and this is y, if this is z and this is, let's say this is q, the law says the two angles that are opposite, that is q plus z, will be equals to 180 degree. And so also x plus y will be equals to 180 degree. Supplementary, don't forget we've explained supplementary angles in our angle theorems. Now, when you add these two angles together, it will give you 180 degree as long as they're opposite. Please take note. The faces of the quadrilateral are touching the circumference. Okay? Now, what is a quadrilateral? A quadrilateral is a shape with 4 sides. Okay? Now, we have square, we have rectangle, we have rhombus, and so on and so forth. These are examples of a quadrilateral. Now, if I have a circle and let's say 3 of its faces are touching the circumference, but one of it is not touching the circumference, automatically the two sides cannot be supplementary. These two sides, despite that the two sides are touching, they are not supplementary. The 4 faces must be touching, the edges of the quadrilateral must be touching the circumference of the circle before they can be supplementary. Okay? If you have understood this, then we can proceed to the last theorem. Now, the last theorem says, theorem 6, which is our last one, theorem 6. Theorem 6 says, exterior angle Theorem 6 says exterior angle of a cyclic quadrilateral is equal to the interior opposite angle of the quadrilateral. Okay, now when I have a circle and I have a cyclic quadrilateral, assuming I have a cyclic quadrilateral, apology please. Now, assuming that I extend this line, this is a straight line. Now, the law says that the angle that is here, this angle that is here, and the one that is opposite this angle, this is the exterior angle. This is the exterior. And this is, we have three interior. This one is alternate to this. This one is alternate to this exterior. It's not opposite. This one is corresponding to this. In mathematics, in angle, we only say this one is alternate. Okay. You're not understanding. When they say something is alternate, in our previous class, when I explained alternate angle, we're talking about Z angle. Okay. Like a corner of your arms. Okay. Now, when we're talking about corresponding, when we have something like this, we're talking about F angles. Okay. When we have something like this, F angles. Okay. Now, but in opposite, we are not talking about this. If you see, this is like F. See, like F. Okay. This is like Z. This one is like Z. Okay. You see, let me use red pen to trace it. You see, this is like Z. Okay. We're not talking about this angle. Now, we're not talking about this angle because this is corresponding. This is like F. Let me clean this so that you understand better. Okay, you see? So this angle is a corresponding angle to this. They are not equal, but they are in a corresponding manner. Okay? This angle is an alternate angle to this exterior angle. They are not equal, but they are in an alternate manner. Okay? It is only this angle that is opposite to this exterior angle. And this angle that is opposite to this exterior angle, the law says they are equal. Okay? Now these two angles are equal. The exterior angle of a cyclic quadrilateral is equal to the opposite interior angle of that quadrilateral. Do you understand now? Now, in our coming class, we're going to see how we can apply these theorems. In some questions, in most questions, you have to apply like 4, 3, or 2 of these laws before you can be able to solve completely the angles of the circle. Now, follow me in my coming class. Join me in my coming class and try to subscribe to my channel. Thank you so much. Bye.